So now in this video we modified the basically pulse generator that I made with a capacitor and NPN bipolar junction transistor. We are using 2 volts at the power supply, and as you can see we can charge this capacitor, that's what we're measuring right there, above 2 volts. And the quicker I press the button, the faster it will charge. And it doesn't really matter how long I hold the button. That's why we wired it as a pulse generator. Otherwise we'd be wasting a lot of current for me holding it too long. But in any case, there you can see we can really easily get to 4 volts, but this is a small value capacitor and it has leakage. It's going to self-discharge over time. If we press it really quick, you can see we can get, it's going to take a while to go up as well, but we can get really close to 6 volts, and I was able to pass 6 volts, but I'm not going to bore you with that. So now first off, I'm just going to note I got this 1000 microfarad capacitor. Exact value doesn't matter at all, but it's across the supply rails right there, and that's just because this power supply can't provide instant change in current when you have a sudden demand for it. And so this will provide a little bit of current when we have an instant demand for it. It'll help stabilize the supply voltage. And now to the circuit here. In the last video we looked at, we can press the button in the circuit. We had a high value resistors in that video if you saw it, but now they're lower because we want more current. So press the button, the current will flow, the capacitor, this side will get more positive, that side more negative, current will flow to ground right there. That's the basic thing. When you have base to emitter current, there's collector to emitter current. So we lit an LED in the last video, if you saw that one. Now that current is going to flow through a coil. It's going to allow a current to flow. But the main thing is, even if we hold the button, so we want current to flow through the coil, but not forever in this video. We want to cut it off basically as soon as the maximum current is flowing through it. But if you hold the switch, the transistor would stay on except for this capacitor. So DC, direct current, does not flow steadily through a capacitor. At some point its voltage rises to the supply voltage and current comes to a stop. So you have to change the voltage to change either a higher voltage to keep it flowing in one direction, or drop the voltage so that it goes in the other direction. Now that will come to a stop, and thus it will try to stop current flowing through the inductor. But inductors don't instantly conduct current, so we have to have it long enough that it does conduct fully. But at that point you want it to stop, and so once the transistor stops, now there's only one path for the current to flow, because it's not going to stop instantly, and that's into the capacitor there, or out to a load if you had a load. And so the capacitor, though, its voltage depends on how much current is in it. So if it already has a higher voltage than the supply voltage, the inductor doesn't care. It's going to keep pushing current, and then more current, its voltage rises, and the process keeps continuing. So zooming in to get a better look, I took a 100 ohm resistor to basically set the current that's going to go into base emitter until the capacitor is charged. I just tried different values, and this one seemed to work okay right there. So we close the switch, it connects those 2 points, and current flows that way. A little bit of current's going to trickle down that way as well, but shouldn't really make a difference. We kind of need that resistor. So 0.47 microfarad capacitor, a low value here. Different value may work a whole lot better, I don't know, but this works just fine. Now we come to the there's another resistor here. Let's do that one right there. So that's going to the base as well, and that gives us a path for the capacitor charges this direction, and then we need it to discharge right here. So that side's going to get more positive, so it pumps that way, and then it can discharge when we release the switch, but not until we release the switch. So if we hit it too rapidly at some point, it won't let the capacitor discharge completely. Stuff you would have to worry about if you're designing a circuit, but honestly, just buy a boost converter. It does the same thing. But they're well made and they're pretty cheap. But this is still a fun prototype circuit to build. Now let's just remove the coil. So the coil is between this orange jumper, 2 squares above, or 2 rows I should say, above the collector up there. So collector there. That's where we were bridging the inductor. and then the base there you can see capacitor and the resistor there. This diode is also to the collector, as you can see there. So now I'll return it. Hopefully that all makes sense. And this, as I said before, current base to emitter turns the transistor on, can conduct collector to emitter. Capacitor is going to charge though, that's going to cut current and stop it. And so now let's talk about this part of the circuit up there. We got the diode. The inductor I'm using is a 10 millihenry inductor. I got a bunch of them, pretty low priced. And from testing earlier videos and stuff, I found they have about 25 ohms of resistance. So inductors are kind of thought of as perfect, or inductors are kind of thought of as perfect conductors once they start conducting enough. But I don't know how much resistance most of them have, but I know this one had about 25 ohms. So we can short it to ground, and especially at low voltages, it's not going to overheat. When we cut the power though, as I said before, it's going to keep conducting. So that is the amount of current is determined by the conductance value there. So higher inductance value, it's going to pump even more current into the capacitor. So if you buy a boost converter, probably has a much larger inductor. That's one of the things. And but in any case, the diode lets the current go that way, charge up the capacitor without coming back, because it could discharge back to the power supply even, but it can't. This side has to be more negative, that side more positive. So you pump that in, then this side becomes more positive. It can't go back that way. We probably saw, if you were paying attention, the voltage of the capacitor went down right after I pumped it up every time. That's because there's leakage. It's not a perfect capacitor. Again, you'd want like higher value capacitors if you're making a practical circuit. But again, just buy a boost converter module. I'm not going to try to, and maybe I will just to challenge myself, but I'm not going to try to make a perfect boost converter circuit, because I think that's your best option. You can just buy them. So in any case, I hope you enjoyed.